All right, Mr. Alent here, going on to examples 2 and 3 for finding the areas of regular polygons. And so we found one just now where when the apothem was the given. Now we're going to look at what if the side is what's given. All right, so if you look at this, it looks like we have a hexagon, 6 sides. 6 sides is hexagon. The side length's 8. We still, right, here's our goal. We're trying to find its area. Area, the formula for any regular polygon, is 1/2 times p times a, where p is the perimeter and a is the apothem. Okay? So, where do we start? Well, like it says up here, step 1, find the central angle. Again, I said in the previous video, every one of these problems, first thing to do is find the central angle. So let me just draw it real quick. Remember, central angle is when you have 2 consecutive vertices drawn to the center. This angle here is the central angle, right? And so central angle is going to equal, and you do 360 divided by the number of sides. This isn't a hexagon. It's got 6 sides. 360 divided by 6. Okay, and that's going to give us 60. So this is a 60-degree angle in here. Okay. But then, again, we don't really use the central angle except to use half of it. So we have half the central angle. Okay, and why do we need half of it? Well, let's go back to the picture here. We need to draw in our apothem, right? For every one of these, we need to know the apothem. That little a stands for apothem. And the apothem is drawn from the center down to a side. And, you could draw it to any of those sides. I just tend to draw down. It's the easier way to go. It comes in at a right angle. Okay, and what we do is we then create triangles, right? We create some triangles. And let me go ahead and make the triangle here with maybe another color. Right there. So there's a little triangle. So this is, again, the apothem we just drew. And that 30 degrees, this is where that comes into play. This is 30 degrees right here. Okay, that's half the central angle. The apothem bisects the central angle. So it's going to be half that 30 degrees, that angle right there. Here's the triangle that we kind of are giving you to work with, and so it's going to match this triangle, and we kind of have it oriented a little funny, but that's okay. This is the right angle. So this is like the side. Here's the apothem, right? It's the longer leg of our right triangle. We don't know the hypotenuse. We do know that this angle is 30 degrees. And we do actually know this side as well. This other leg is going to be 4 inches. Now, where did I get that from? That's coming from here. When we drew the apothem down, it bisects that side. It cuts it in half so that these are both 4. There's a 4 there, and there's a 4 there. Okay, so the apothem bisects the angle. It also bisects that side when you draw it there. Okay, now let's go back to our triangle here. What we're trying to find, guys, what are we trying to find? We're trying to find A. Right, we need the apothem. It is unknown right now, but we've got an angle, we've got a side, perfect trig scenario. All right, so again, every trig problem goes the same way. Identify sides. And there's the hypotenuse, there's the O, there's the A. Just coincidence that A is A, right? This is this capital A stands for adjacent, little a stands for apothem, right? Opposite and adjacent. Looks like we've got O and A. That's going to be another tangent one. So the tangent of 30 equals the O, which is 4, over A. So when it's the variable on the bottom, remember those basically swap spots. Think back to last chapter. So it's 4 divided by the tangent of 30, which in your calculator gets you a 6.9 inches. So the apothem is 6.9 inches. Okay. We don't know the perimeter, but it's actually very easy to get. Basically, we're given it because the side lengths were given, right? So perimeter should be a piece of cake here. Perimeter, we've got 6 sides, so it's 6 times the side length, right? The side length was 8. So my perimeter is 48 inches. Okay, we now have everything we need. We got A, we got P, that's all we need. Area is 1/2 times the perimeter 48 times the apothem 6.9, which is going to give us 165.6 square inches. .6 square inches. Okay, there you go. So there's when the side is what's given. Now let's go to the last one, example 3. This is probably the hardest one because in both the previous video, when the apothem is given, you've got half of the battle here. You've got A, we just had to find P. Down here, we pretty much had P. I mean, we had to do, very little work to get it because we're given the side length. You've got P. We had to find A. Now, for the last example, we're not given either. We're still finding the area. We need P and we need A. We have neither of them. Neither, however you say that. So we're going to have to find them. Starts the same way, right? There it is. Step 1, find the central angle. Okay, so nothing changes as far as that. That's good news, right? We can get into the habit of, before we do anything, finding that angle there, right? So the central angle you find by doing 360 divided by the number of sides. This is a pentagon. 1, 2, 3, 4, 5 sides, right? Pentagon, 5 sides. 360 divided by 5 is 72 degrees. So our central angle is 72 degrees. But again, we don't care about the central angle except that. We care, but what we need is half of that. So cut it in half. 72 divided by 2 is going to give us 36 degrees. We need that for our triangle. All right, remember the triangle is always half the central angle. So if I again go to my picture, draw the apothem right there. There's the apothem. I'm going to call this little piece X right here. We need to find both of those. And we do have this angle, that little guy, that's the half the apothem, so that's the 36. Okay, so if I'm looking back at this triangle again that we're using, we're trying to orient it right in your head, right? The hypotenuse is 9. Here's my right angle. Hypotenuse is 9. The long leg is A. The short leg is X. And up here is our angle 36 degrees. Okay. Now, as far as difficulty, this isn't any more difficult, I should say, than the previous ones. The only thing is we're going to have to do trig twice, right? Before we did trig once for each problem, that was good. This time we have to do trig twice. We're going to find A and X. Trig, you could do trig once and Pythagorean theorem once. If you find use trig and find one of the sides, you now got 2 sides, and you're looking for a third, you could do Pythagorean theorem. The issue I take with that is sometimes, what if you did your trig wrong? And then you're using that wrong answer in Pythagorean theorem, now your other side is also wrong. And so you're going to be wrong for both. But, maybe you messed up one but got the other one right. You could be half right as far as finding these. And so when it comes to like giving partial points or something, being half right is better than being totally wrong, right? Okay, so here we go. Let's label, right? Every trig problem starts the same. O, A, and H. All right, so if we're finding, let's find A first. It's the first one we see there, right? So to find A, we'll put a little line there. We'll separate the two, and then we'll get to that one. Okay, so to find A. So I'm looking for little a. It looks like little a is A for adjacent, and then we're going to use the 9 for H, right? We don't want to use X. We don't want to put A and X in the same equation. That would be terrible, right? That would be putting 2 variables, 1 equation, bad idea. But the A with the 9, that's a good way to go. So A and H, that's a cosine, right? Think back to SOHCAHTOA. A and H is cosine. So the cosine of 36 equals the adjacent, which is A, over the hypotenuse, which is 9. Variables on top, so I'm going to multiply both sides by 9. So A is 9 times the cosine of 36. which is going to be 7.3, and this will be meters, right? Look back over here. We're looking at meters. All right, so the apothem, we've got the apothem now. We're halfway there, right? Halfway to what we need. All right, let's find x. So to find x, same idea. We're going to use trigonometry, but this time x is O, and we're still going to use the h. Use it again. Use it again. Don't use like O and A, because again, what if this was wrong? What if you did something a little bit wrong, didn't catch it, and you use it to find the other one? Now you're in trouble, right? Double trouble. So let's just stick with the thing we know, right? So O and H, that's a sine function. So the sine of 36 is O over H, so x over 9. So it looks like x equals 9 times the sine of 36, which is a 5.3 meters. Okay, now remember though, like before, x is only half of the side length. So to find the whole side, you need to double x. 2 times 5.3 is a 10.6. Okay, we need that because now we're going to find the perimeter. So perimeter, we've got 5 sides. All of them have a length of 10.6, right? And that's going to give us, it's actually a really nice 53 meters. Okay, we're there, we're ready. Remember the end goal here, right? The whole purpose to all that was we were trying to find A and we were trying to find P. We now have them both. There's A, there's P. Plug it all in. Whew. These problems are involved, right? 1/2 times P times A. And just doing that arithmetic, you're going to get 193.5, and our area was in square meters. Okay, so again, there's the 3 types. Radius is the most involved if you're given the radius, because that's when you, let me zoom out a touch, see if we can, oh, I am zoomed out as far as I can. Given the radius, that's the most involved because you're going to have to use trig twice to get both the apothem and half the side, to then double, to then get the perimeter, so you can have P and A to put in the formula. The other ones were when we were given a side, right? So given a side, now this given a side is essentially giving you the perimeter. So really what you're having to find then is A, little a, the apothem. And we use trig to find that. Don't forget we're getting half the central angle every single problem. And then the other one was when the apothem is the given, like there in the 4, we're going to have to find the side length. We found x, which is half of the side, so we doubled it so we can know the whole side. And then found the perimeter and the area. Okay, well there you go, guys. This is, like I said, is very involved. This is a tough chapter with that. That's the newest stuff. You guys have never had to do that before. We've seen areas of other things prior to now, but certainly not these regular polygons. But it's pretty slick, and they all do behave the same way. I know there was a lot of process, but look at the steps. They're almost the same in all 3 problems. So keep these close. Look at them as you're trying problems. Good luck, guys.